Hi students, today we're going to investigate the properties of quadratic function, and here is our quadratic function. So to know the properties of quadratic function, we're going to investigate by using completing the square method. So we're going to say that f of x is going to be a. If I take a out of the bracket, you have x squared plus b over axc plus constant. So now I have to find a number which, when added to this expression here, I'm going to get the perfect square. So it is like you are actually taking a x squared plus b over axc plus a number, call it k minus k plus constant. So k will make the expression, this expression here, a perfect square. So dear students, f of x will be now equal to, so k is going to be b over 2a square, and actually this is coming from the formula b square equals to 4ac. So when we substitute here, you're going to get this expression here. So f of x, dear students, will be reduced to a in the bracket x squared plus b over a x plus b over 2a square minus b over 2a square, you close the bracket, plus c. Now we have this expression here. It is already a perfect square, so f of x will be equal to a x plus b over 2a square minus, I'm going to open the bracket, it will be b square over 4a square plus c. So when you open the bracket, f of x will be reduced to a x plus b over 2a square minus b square over 4a plus c. So we're going to combine now the expressions. So f of x will be a x plus b over 2a square plus 4ac minus b square over 4a. We just simplified this side expression, dear students. So as you can see, now our function has been reduced to a form which is very easy actually to interpret, and we are going now to come out with this with some properties, when you consider some conditions. So from this expression, so now I'm going to reduce f of x to be y, so that you have y minus 4ac minus b square over 4a. This is equal to a in the bracket x plus b over 2a square. So from this expression here now, dear students, we are going to go step by step. When a is positive, so when a is greater than 0, it means a is positive. It is obvious that the expression here a x plus b over 2a square is going to be also greater than 0. So if that is the case, we can say that actually y minus 4ac minus b square over 4a is going to be greater or equal to 0. And from this expression, we have y equals to 4ac minus b square over 4a. So this is y greater or equal to 4ac minus b square over 4a. And from this expression, the function y minimum is when we have equal sign, and that is 4ac minus b square over 4a. So the minimum value of y is going to be 4ac minus b square over a. And this is the case actually when x plus b over 2a equals to 0. So this is when x equals to negative b over 2a, dear students. So as you can see, we have minimum value of y and we have the value of x, which is giving us the minimum value. So we can find the minimum point. So minimum point actually will be y minimum, comma, negative b over 2a. But we know y minimum, of course. So y minimum is 4ac minus b square. Oh, I'm sorry. This is about to be x comma y. So we have negative b over 2a comma y minimum. Okay. So the minimum point now is going to be negative b over 2a comma 4ac minus b square over 4a. So that is minimum point, dear students. Now we are going to consider similar case when a is less than 1. When a is less than 0, it means that a is negative. When a is negative, then we are going to agree that the expression, which expression? We are going back. This expression here, it means a x plus b over 2a square. This expression is going to be also less than 0. Okay? But it is also to be 0, so it means it's going to be less or equal to 0. So for that case, the value of y, so y minus 4ac minus b square over 4a, even this expression here is going to be less or equal to 0. So basically y is less or equal to 4ac minus b square over 4a. So from this expression, you can see that actually y maximum is going to be obtained when we have equal sign, and that is 4ac minus b square over 4a. And this is obtained when x plus b over 2a is again 0. So that is actually when x equals to negative b over 2a, dear students. So now we have the value of x, which is giving us maximum value, and you have y maximum. So we can say maximum point is equal to negative b over 2a comma 4ac minus b square over 4a, dear students. So the expression for finding maximum or minimum value is the same. As you can see here, minimum point is the same as maximum point, dear students. So we can say that actually maximum or minimum point of a quadratic function is the minimum point or maximum point of quadratic function is minus b over 2a in the bracket 4ac minus b square over 4a, dear students. So that is how we are determining minimum or maximum value. So the line xc equals to negative b over 2a, this is called axis of symmetry. This is called axis of symmetry, and this is the actual axis of symmetry of the graph we are going to draw, the graph of quadratic function, dear students. And the point at which the quadratic function attains its maximum or minimum value is called the turning point of the function. So turning point, actually that is maximum or minimum point. So you can be asked to find the turning point, and in turning point, dear students, will be again minus b over 2a comma 4ac minus b square over 4a. So that is how we determine the properties of quadratic function. For more details, we're going to continue with some few examples in the coming session. Thank you.